The question is to find a basis for the subspace H of R4 defined by the following two equations. In other words, H is the solution set of this linear system. We start by finding a spanning set of H, and then we verify that this spanning set is linearly independent. Now, a vector x, y, z, t is in H means exactly that x, y, z, and t satisfy these two equations. The augmented matrix of this linear system is the following. And this is a row echelon form of the augmented matrix that indicates that the variables x and y are basic and the variables z and t are free. The previous system is therefore equivalent to the following system, which is equivalent to, therefore we showed that a vector x, y, z, t is in H if and only if t equals x and z equals y, which means that x, y, z, t can be written as x, y, y, x, which is x times the vector 1, 0, 0, 1 plus y times the vector 0, 1, 1, 0. Now, if we call this vector u and this vector v, we showed that any vector in H can be written as a linear combination of u, v, which means belongs to span of u and v. In other words, we showed that H is a subset of span uv. Again, this means that any vector in H is a linear combination of these two vectors u and v. Now, the other inclusion here is straightforward, and for that it's enough to notice that u is in H because the vector 1, 0, 0, 1 satisfies both equations that define H, and same for v, which means that any linear combination of u and v is also in H, since H is a subspace, so it's closed under linear combination. These two inclusions together mean that H is spanned by u and v. In other words, the vectors u and v span H. Additionally, the set uv is clearly linearly independent because this is a set of two vectors and none of the vectors is a multiple of the other. In conclusion, the set uv spans H and the set uv is linearly independent, which means that the set uv is a basis for H.